Hello, I'm Conrad Wolfram,
And I'm Jon McLoone.
and this week's Computational Conversation podcast is a discussion on what makes maths fun. So, Jon, why is maths fun to you?
I think not all maths is fun. I mean, that's perhaps the first thing to say, that sometimes there is work to be done. But actually, for me, maths is most fun when it's something creative, when is not clear that you're going from A to B in some decided format. That's just work. What's fun is when there's a whole collection of interesting questions, interesting approaches, different things that you could try and do, and you're never quite sure, or when you're not quite sure, what the outcome is going to be, or whether you've thought of the best approach. And then it's very much an act of creativity, and that's where the fun lies for me.
But I mean, the majority of the population think there's absolutely no fun in maths at all. I think it's a horrible grind. So, what are they missing?
Yeah, well, I think that creativity actually is back to a lot of the problem there. There's a lot of things that you would think might be fun, like art, that if you were just, being a painter might be a fun creative act, but having to paint the walls in a house can be pretty boring. So it's down to the freedom to express yourself that I think is one of the problems. And of course, a lot of maths education, which is most people's experience with maths, is very much is the chores of practicing things. It's not, little time is spent actually really being creative or discussing.
Well, I must say, at school, I kind of hated art classes, but that wasn't because I hated the art. I just was useless at them. And so I think one of the issues is whether you think you're any good at it or not.
Well, yes, and some of that is going to be the feedback you get. That I suspect a lot of people enjoy classes where their teachers say they're doing a good job. And maybe you didn't get that, maybe you weren't very good at art, I don't know. But I think when you can objectively say you've achieved something, then I think that adds its own reward. Now, art, you have to look at something when you're done and say, I'm really pleased with what I did. That's got somewhere interesting, or it was what I was trying to achieve. I think in computational thinking, some of that comes a little bit more automatically, because you can discover something that, when you've discovered it, you've got an answer, which is perhaps not the same for art, of knowing whether you've created something good.
What's something you've done recently where you thought, hey, that was fun to do?
Oh, recent things. All the ones I can think of a while ago. I was doing some interesting things, actually, exploring some of the uses of principal components analysis. This is going to get far too technical. It just happened to be a thing where my daughter was
what
using
Jon does in his off time. Yes, carry on.
Yeah, so this is it's a data science thing for being able to figure out what are the influences of in your inputs, which are the things that are most helpful towards making a prediction. And it's a mechanism for figuring out what's important and what isn't. It's something I'd learned about, I'd used as a tool. I'd never really thought about it, though. So for me, just spending a bit of time playing with our different data sets and trying to get an intuition, that was fun. Perhaps it's not, everyone's cup of tea, that one, but I think things that people appreciate more probably are the pure recreational maths things that I've done over the years. Like, if you Google my name, you'll still find impact of finding the hardest hangman word ever, which was just a random blog that I wrote for the company.
Which I think appeared on at least one UK TV show.
Yes, it was a question on QI, which it's less so now, but it was quite a big quiz show that was on British television. I think it's been exported to other countries, and I didn't even know it was coming on. I was just watching it with my wife, and suddenly they said, "And what's the hardest hangman word?" And we're looking at each other, going, "Is that my work? Is that what's going to get quoted now?" And it was all based around that blog that I wrote. But that's one of those things where it's like there's an interesting question. I wrote a hangman game because I was interested in the algorithm of choosing words, and I wrote it both ways around. You as the picker, and the computer has to guess what you chose, and one for you to guess what the computer chose. And then it was a conversation with my daughter where we were talking about, what if we got them to play each other? And then we started hatching out the question, which is, well, what's the hardest word? There must be something that is objectively the hardest word to guess. And so I wrote some code and ran a few hundred hours of CPU time, and we had our answer, which was jazz, by the way, JAZZ.
So why was that so hard?
Short words tend to be good, it turns out. That was a side discovery. Words with double letters tend to be.
Is that because you don't hit you have less chance of hitting a letter, basically?
Yeah, so with Hangman, every time you go wrong, you lose a life. So imagine if you had a 26-letter word that had all the letters in, you could never go wrong. So short words tend to be harder, but then if you go too short, there's not many of them. And double letters make longer words have fewer, the number of letters of short words.
So you must be assuming some particular algorithm for how one picks the letters.
Yes, it is assuming that you are effectively doing a kind of dictionary elimination. That once you know certain facts, you can throw out all the words that don't match those facts, and then you're left with a bunch of words, and you're going to pick, in a kind of game theory sense, the randomly from the most frequent letters in the words that you have left. So if all the words you have left have an A, and you'll pick an A, but if only half the words have an A and half the words have a Z, then you might pick evenly between them. So that was the base algorithm, which I kind of believe is sort of intuitively how we're working as humans on that, though not proven.
So I have a funny set of things that sometimes I find interesting. I mean, I like working out problems where there's a practical thing I'm trying to work out, center of gravity of an aeroplane or something, and it's quite nice to be able to compute that. The thing actually in the last few days is it's been extraordinary to see some of our new notebook assistant capability with AI assisting the writing of code, which you are much, much faster at and better at than I am these days. And, actually get assistance on just uttering something to get code out has been really fun to see real mathematical things. So I told it, write some Wolfram code for generating a polyhedron with X sides, and let me play with that. And there the code came out. It's just fun to see you instructing a machine to do something like that, and it works. And it's even more fun when you don't even have to do some of the hard labor.
I think when you've got these slightly magical tools as well, and some computations like that, there's a lot of fun in just figuring out what really are they capable of, what's their limits. And very much we're in that world right now with these LLM-based tools of, is it really capable of writing good code? What if I ask it something really hard? But the same kinds of things are true in lots of computation. When we first got machine learning, I had a lot of fun trying to figure out what kind of computer vision things worked well and what didn't. I wrote something to recognize, the gestures of rock, paper, scissors. Really easy. Machine learning was excellent at that. I tried to do, those spot the ball competitions. I don't know if this is a British cultural thing where they take a photo of a football match, but the football's been removed or is out of frame, and you have to guess from where everyone's faces are pointing where the ball would be in the picture. And so I tried to get, computer vision, machine learning techniques to try and make that prediction. That was not very successful. Turns out to be much.
Actually, I wonder how I would do that, because I'm so profoundly uninterested. I would be probably looking another way, and it would confuse.
Well, I'm not at all interested in football either, but it's as a kind of like, can we machine learn the geometry of which way you're facing, take the lines and where they intersect, and build a kind of area of probability out of that. That was kind of, so again, open-ended problem solving.
Do you think these modern AI tools are going to help more fun to be spread across the population about maths or computation?
Yeah, I think so. I think they're not going to take away from it. They're going to add to it, because the kind of the chore of maths is even further removed from the experience. So there is more time to be had on interesting questions and discovery than there used to be. A lot of things I found fun are just pure discovery. I wonder what is a great start to a question. So when I stumbled upon the API for food hygiene in the UK. There's an inspection service, government exposes data, and it popped into my head. I wonder where the most unhygienic food is in the country. And there you go. You've got a motivating question. You do a bit of data science, and you get your answers. And you can read the blog for that one. There's all kinds.
Yeah, that's good. That's on your.
I had a very simple API, and yet I discovered half a dozen things that are not totally obvious just by playing with the data.
Yeah, so I think there are probably several kinds of fun to be had, which are a bit different, right? So, I mean, at one level, it's working something out where you think you can work it out, which other people can't.
Or just have never asked the question is,
yeah,
I think the most fun for me.
I mean, there's the pure competitive thing, right? Can somebody do it better than somebody else in some exciting way? And I suppose the AI thing is interesting because it's slightly different direction of things. I mean, traditionally, maths, specifically maths in education, has been about sort of, in a sense, doing the mechanics, yourself. And there is a fun to that. I mean, I found it quite fun doing some of the mechanics of maths, even though I I argue against that being the mainstream subject in many respects. I found that actually doing some of it can be quite fun, and motivating in some cases. But that's because I think that was partly because I was better at it than French.
Yes.
So, French, I was useless. And basically, whereas maths, I thought I was doing relatively well against other people. So I don't know how much the motivation was intrinsic and how much was competitive.
Yeah, I think the competitive is a winner for a minority, because in the end,
Well, it can only be a winner
if you're
for
a winner,
minority.
and there can't be that many winners. So
Quite.
the Olympiad problems are like that, people competing to somehow be the best. And when I think about all of kind of purely recreational things I've done, I can only think of a couple that are competitive, where I got in a battle with Danny Lichtblau, one of our top algorithms people, over maze solving, and he came up with a better technique than me for solving the photo of a maze from aerial satellite photography, and so I had to come back with something better. And I guess the coding competition we have at our conference, I have fun at, but most of the time it's for my own pleasure.
Is that the one-liner competition?
Yeah, the one-liner actually. Okay, that's also I also competed in the internal version of the one-liner competition, which was very much a creative thing. But there's the pure code speed competition, who can solve this problem the fastest, that I won one year at our conference, where it's just you've got 30 seconds to write some code that solves some problem you've only just heard.
Because we have the programming competition where it's like who's got the neatest code for doing this. And then we also had I guess they're rather out of date now. We had a little tweet a program thing where it was like you had 160.
We still run that.
No, I know, it's
the
just
best program you can write in 100 and whatever characters.
It's not called tweeting anymore technically, but yeah. But that was quite fun in terms of how neat can you I suppose I like looking at the results of that, because I liked seeing people's different way of thinking about the same problem. And so I find some of the things that I actually find interesting are nothing to do with the calculations. They're to do with mathematical ideas of how you structure things. I was thinking about various aspects of how to structure the company, for example. And, I think of basis sets in geometry. Which way round are the axes? Are they orthogonal to each other? And, when you think about departments in a company, and, do we have, I don't know, this is very simplistic. Do we have marketing, sales, and some sort of technical? And do we have it UK, France, Germany, for example? And those are different basis sets. How do you organize that? What's the predominant axis, et cetera, et cetera? So I quite enjoy thinking about mathematical forms of human problems in that way.
So I think what you're hitting on there, which I have a different version of, is sometimes the pleasure is in the kind of more abstract thought. It's the elevating yourself even further away from the details, but just how do you, the conceptualization. And, some of the things I quite like doing, if you look at some of my past blogs, are just trying to figure out, what if I apply this area of maths to something completely different? What would that mean? So things like when we first got graph theory, I would just look at some of these new functions in the graph theory packaging that we had, and thinking, what would that mean if I applied that to words? So the longest, shortest word ladder puzzle that I solved, that I got contacted by the Guinness Book of Records about whether they could use it, but in the end they didn't use it. But that was really, we got this conceptual thing, graph periphery, as a function. What does that mean in the context of the chain of words that are one edit distance apart from each other? You start realizing that you're picking the words that can be joined up by this game of word ladders, but are the longest one from one side of the conceptual space to the other. And this idea of sort of putting things together. I did the same thing with shortest path, standard graph theory algorithm. Why is that fun? Well, shortest tour are, if you take the rules of knights move on a chessboard, solves this ancient problem of the knight's tour. Can you make the chess piece land on every square on the board once and just once? But then you start thinking, well, the chessboard is just like, it's like an image with pixels, white and black pixels. Why couldn't it be any other image? So I started solving that over letters of the alphabet, or totally pointless. But the conceptual idea of mixing graph theory and connectivity of squares and rastered images like the shape of a Pac-Man symbol, I think it kind of amused me that you can put these different areas together and come up with something that solves a real puzzle.
But what about puzzles and games in general? And working out, I mean, like, obviously the archetypical one would be chess. Is that something that you like figuring out the mathematics on? And do you think games are as motivating as they're claimed to be? I mean, I worry sometimes that in education, for example, people are basically doing something bloody boring, which is sugar coated by trying to put a game over it, which, you know, as in there's the sugar, and then you get down to the medicine. But I think games intrinsically, for some people, not everyone, I think, is quite motivating. I guess it depends which games, what type.
Yeah, I think there were games that are kind of fake gamification on a maths puzzle. They make it fun for some people, but to me, it's always felt a bit fake. And I think there's a difference between puzzles and games. Games are competitive, so it's, you know, if you play games you like to win. I like to think about strategies of games. I've done a couple of blogs on that, things like, you know, what the first mover advantage is in games like Yahtzee, or the odds that you get. But whereas puzzles are rather self-serving, they're sort of on your own. And I've never really liked so much these artificial puzzles where somebody's set up some complicated thing that you have to try and figure out what the answer is. I much prefer the kind of self-evident puzzles of real-world problems. And there's plenty of puzzles out there to puzzle over that.
But funny, I actually just went to a conference in the last few weeks about the 50 years of the Rubik's Cube. And you know, various people representing Rubik's and so forth. This was in Cambridge, the conference. Well, of course, it's Hungarian originally. It was funny to see who that pulled together from very well-known mathematicians to discussing how this should or shouldn't be in education. It was funny because I think there's some sort of resurgence. I mean, I remember the Rubik's Cube when I was at school. I was pretty lousy at it, but there were people who were incredibly quick at figuring it out and enjoyed that, found that a very fulfilling thing to do.
Yeah, well, I could solve the Rubik's Cube once, a long time ago, back in the 80s when it was the first to fad. My daughter can do it now 10 times faster than I ever could. She is more in that kind of mindset of you know, learning the rules and applying the rules of the cube. To me,
is that your computer science or engineering?
That's my engineering daughter. So I've got a computer science daughter who I think is totally disinterested in the Rubik's Cube. Although she's much more into competitive games, and my younger daughter is the engineer, is the one who's kind of more into what you would consider nerdier pastimes, and so she really likes it. But to me, mathematically, I've never been interested in the Rubik's Cube. I think there's a lot of graph theory involved, which I never liked. Not graph theory, sorry, group theory, which I never liked at university. It all seemed rather pointlessly abstract, not usefully abstract. And permutation type work also, which I never found very interesting. So for me, I've never tackled anything to do with Rubik's Cubes, and they also feel like solved problems at this point.
So do you think, we probably should wrap up, but do you think that fun for everyone in maths is what we should aim at? Or should we aim at deep fun for a few people? Or should we not aim at fun at all? And it's just a pragmatic, use. I mean, the term maths itself is slightly off-putting, but computation or computational thinking, do you think it's something where, you know, we can get lots of people to see it's fun and that's a good direction, or whether we shouldn't? That's not really what we should aim to do. We should just try and, you know, use it for what it is and have a few people hive themselves off and test different kinds of fun on everyone and see whether they like it.
Well, you know, life should be fun. I think it seems then therefore obvious to me that if things are important like maths, we want them to be fun. That shouldn't come at the price of being useful. You know, we shouldn't just do fun stuff. We've got to do useful stuff, even if sometimes that's not the fun bits. Just like, I guess, if you play an instrument, you have to learn your scales at some point, or, you know, these other kind of, or fingering chores or whatever it is you need to do in order to be good at things. But I think for me, the main realization for me is that there isn't one kind of fun. There is people who love to be able to do Olympiad challenge puzzles that are, you know, difficult and self-contained and not necessarily useful. There are people like me who have a mix of liking discovery and high concept ideas, and there's people who just like being good at things, and there are people who like the really boring minutiae that I personally don't. So we need
maybe the summary is
people can find the fun that they need.
It's a sense of achievement, but that sense of achievement differs quite a lot, and it's usually quite fun to feel some sort of sense of achievement, even if it's on something esoteric, which other
I've
people
done things that were
see.
utterly pointless and really loved them because because there was just something interesting that emerged, even if I don't know if interesting and discovery are achievements, but sometimes just coming away thinking about things differently is in itself a reward.
Well, I can't think of many subjects that bifurcate between loving it and hating it as much as maths does. But perhaps on that note, we should probably call this podcast to a close. Fun though it's been on a grey day in England. And anyway, hope you've all enjoyed it and look forward to seeing you next time for the next episode of Computational Conversations.
Goodbye until next time.